One variable statistics, histograms, and interpreting data. Mean, median, and mode are measures of the blank of a data set. Well, they are measures of the center of a data set. The shape of a data set tells us important things about the mean and the median. When the data is blank and blank, so we're looking at this right here, how do we describe that data? Well, I can see that if I put a line here, it's about the same over there as over there. So remember, that means it's symmetric. So when the data is symmetric, and when it has this hump in the middle like that, we say that it's normal. So when the data is symmetric and normal, we know the mean and the median are about equal. So if we were to estimate 50% of the data, we would say, yeah, 50% of the data is there and 50% of the data is there. That means this is the median. Let's use a different color there for the arrow. That is the median. And it is also the mean. So the mean and the median are about equal. When the data is, and if we look at this, we can see again that that is symmetric, about right down the middle there. So we can say when the data is symmetric and when we have it flat data like that, we say that it is uniform. So when the data is symmetric and uniform, we know the mean and the median are, well, again, right about there, we can say that that's about the average, the mean, and that's also the median. So the mean and the median are, again, about equal. So that's the same for uniform and normal data. And whenever we do have either normal or uniform data, it's always symmetric. So that's always the case. When the data is, and now here, this data with this long tail out to the right, we say that that data is skewed right. So when the data is skewed right, we know the mean is something, the median. Well, if I think about 50% of the data, so right about there, that looks like to be the median to me. And the mean, though, is pulled out away from the median toward the tail. So the mean is bigger than the median. So when the data is skewed right, the mean is bigger than the median. Here we have data that has this tail out to the left, so it is skewed left. We know the mean is blank the median. Well, that's going to be opposite. So here, the median is right about there. And the mean will be pulled out away from the majority of the data so that the mean is smaller than the median. An outlier is a data point that lies far away from other data points. So if we look at this graph, here is an outlier, and there's all this data right here, and then there's this outlier. And here, all the data is there, and there's an outlier there. Like tails or skewed data, when we do have symmetric data, so this looks basically symmetric, it's about right there, it looks pretty much the same to the right and the left, except for there's this outlier. Like tails, the outliers pull the mean away from the median. When the outlier is bigger than the rest of the data, the mean will be like right there. Well, maybe not that far. Maybe right there. It's the mean, and it will be pulled away from the median. So the mean will be bigger than the median. When the outlier is smaller than the rest of the data, so here we have our median is about right there. Here, the mean will be smaller than the median. And that is what you need to know right now when it comes to one variable statistics, histograms, and interpreting data.